Factoring expressions with fractional or negative exponents. In these examples, we are going to be factoring out terms that have exponents that are fractions. So looking at the first example, 8a, there are two terms that we're looking at in this expression. We've got one term here. Remember, terms are separated by a plus or a minus sign. So we've got this plus sign in the middle that's separating the two terms. I'm looking for anything that's in common to both of those terms that can be factored out to the front. Well, we can see that we've got this 5a minus 1. In the first term, it's raised to the 3/4 power, and in the second term, it's raised to the negative 1/4 power. When we factor, we always take out the lowest number. In this case, negative 1/4 would be the lower of the exponents. So I am going to make this look like I'm dividing by 5a minus 1 to the negative 1/4 power. Again, when I'm dividing each term, that is going to be brought out into the front as we factor. So our next line will have 5a minus 1 to the negative 1/4, and then I want to see what I have left over. In this, I'm going to start with the second term here. In the second term, all of this is going to cancel, and I just have 7a left over. That's for the second term. The first term is a little bit more complicated, so let's go back. For the second term, we want to figure out how these two exponents are going to combine or cancel. So let's do a little side work over here. If I have something raised to the 3/4 power, and then it's divided by something raised to the negative 1/4 power. That's the same as taking that negative 1/4 power and moving it up to the numerator and changing the sign. So it would be, I still have star to the 3/4 power, but then I'm going to multiply by star to the 1/4 power. I'm using star in the place of the base. For us, the base is that 5a minus 1. When I've got exponents like this where the bases are the same and I'm multiplying, I can add the exponents. So this is 3/4 plus 1/4, which is just 1, or it looks like we're just going to end up with just star. Well, again, for us, star is the 5a minus 1. So in this first term, the 2 is still sitting here. Nothing's happened to that. So we're going to have 2 times 5a minus 1. Now we've got to do a little simplification. Inside the parentheses here, we've got some distributing of that 2. So this will be 10a minus 2 plus 7a. We'll leave this alone out here on the front for just a minute. And then if we combine like terms inside the brackets, I'll have 10a plus 7a, which is 17a minus 2. And I can leave my final answer like this. Or if I want to be more grammatically correct mathematically, I can move the fractional exponent down to the denominator and then change the sign to be a positive 1/4. Remember that negative exponent means that I can switch the location and change the sign if needed. All right, let's look at another example. Looking at example B, I've got, similar to the one I had before, I've got two terms. One term is here and one term is here. And it looks like they've both got x minus 1 raised to different exponents as the common item that can be factored out to the front. Just like before, we want to factor out the exponent that is the lower number, and it looks like that'll be a negative 2/3. So I am going to divide both of these terms by x minus 1 to the negative 2/3 power. That is going to come out to the front. And then I've got to see what I've got left over. In the first term, all of this is going to cancel, and I have just a 4x left over. The second term is a little bit more complicated. I've got to see what happens between the numerator and the denominator here. So just like we did on the last example, let's do a little bit of side work. I have something raised to the 1/3 power divided by something raised to the negative 2/3 power. That's the same as taking this item in the denominator and moving it up to the numerator and changing the exponent to be a positive 2/3. If I add the two exponents together, I'm going to end up with something raised to the first power, or just that item. So for this second term, when the dust settles, it looks like we're going to end up with 3 times x minus 1 raised to the first power. Let's simplify what's inside the brackets here. We'll have 4x plus 3x minus 3, and then we'll combine like terms to get 7x minus 3. And we can leave our answer this way, or we can rewrite it without any negative exponents by moving that term down to the denominator and changing the exponent to be a positive number. All right, for this last example, I can see that I've got 3y minus 13 in both terms. The first one is raised to the 1/5 power, and the second is raised to the 6/5 power. So again, we'll divide by the lowest number, which is 1/5. So both terms, we're going to be taking out a 3y minus 13 to the 1/5 power. And that's going to come out to the front. And then we want to see what's left over. For the first term, all of this will cancel, and I have 9y left over. For the second term, I need to see what happens between these two items. So over on the side, we have something raised to the 6/5 power divided by something raised to the 1/5 power. In this example, both of our exponents are positive, so we actually subtract the exponents in this case. 6/5 minus 1/5 is going to be 5/5, or just star to the first power. So for our second term, it looks like we're going to end up with minus 2 times 3y minus 13. All right, let's simplify this. Inside the brackets here, we've got 9y minus 6y and then plus 26. That negative sign gets distributed along with the 2. And that'll become positive. And then just combining like terms, we've got 3y plus 26. This example is slightly different than the ones we just did a minute ago because our final answer and what we factored out has a positive exponent. So it's going to stay on the same line as what we've of kind of what we combined there. It's not going to, it can't be moved down to the denominator because it's got a positive exponent.